Okay, hi Year 12s. I'm looking at review set 3A question 15. And the setup here, let's actually look at the question because it's in the book here. Question 15, so you've got two houses, A and B, there and there. You've also got another house at C, and P is actually a power unit. So the question ultimately will be about minimizing the length of that line there, AP, this line, PB, and this line, PC. Right, so I have tried to just draw a diagram of that. I'm missing my town A and town B, so I'm just going to write that on. And in the first part of the question it says, if the power plant was located over here at M, what would the distance of those lines have to be to get to the three houses? So this is a house here as well. And then it says, if the power plant was located over at C, I'm just going to double check this. If P, the power unit, not power plant, power unit, whatever that is placed at M, and if it's placed at C, what length of line would you be looking at? So we call this part A1, right? So if our P is at M, well, we'd have to have a line 1 kilometre that way, 1 kilometre this way, and 3 kilometres this way. So we'd have 5 kilometres of power line. And part 2, if P gets moved all the way over here to C, you still have to run power to A and B. So you'd have to run the line 3 kilometres that way. No, that's not correct, is it? You could do it like this. Let's try and draw this nicely. If it was located at C, then the shortest way to get to the power, would it be there and there? Perhaps. Might just do the maths on that. So this length here would be the square root of 10. So if we're imagining that P comes over here, so C's already got power with no distance, but then you could run a line directly to A and I'll run a line directly to B, and it would be the square root of, so that green there would be 3 squared plus 1 squared, which makes 10, root 10. But you'd also have to do it that way. What would that equal? I'm just wondering, thinking out loud here. Square root 10 plus square root 10. No, this is not any better. So that's approximately 6.3 kilometres. No, it would be better just to run the line straight through there, 3 kilometres, and then go 1 and 1. So this is all out. It would just be another 5 kilometres there. Okay. All right. I'm not going to be able to erase this very well, am I? Let's try this. Okay, that's better. Sorry about that. So again, 5 kilometres. Okay, part B. I'm imagining that we're going to need an equation for length, but we'll just check the question. What is the length of the cable? They're saying it's 3 plus 2 minus cos theta divides sine theta. Okay. So the length of cable is going to be made up of distance AP plus the distance BP, British Petroleum, plus the distance PC, right? So imagine those 3 lines. Okay. Well, AP and BP will be the same distance, and I can work this out using trigonometry, given this angle here, theta, right? So we know that sine of theta is the opposite divide the hypotenuse. So what's the hypotenuse equal to? Right, so AP and also BP, right, would be 1 divide sine theta. Okay, so you'd have 2 of those. And then you'd need to think about PC as well. So we've got 2 of these. All right. Now PC, it starts with 3 kilometres, but then we have to take away this little adjacent length in here. Now I can get this from tan, all right, minus away this length P to M, right? I'm just going to write a little note to myself over here. Tan theta is the opposite over the adjacent. Right, so there's your opposite. That equals 1. We need to know the adjacent length. So the adjacent length would be 1 divide tan theta. All right. Now, if tan theta, I don't know why I'm saying if, because it is, tan you can consider as being sine on cos, can't you? So what would be the inverse of that? So therefore, 1 on tan theta equals cos divides sine, right? So we'd have to do minus away cos theta divide sine theta, right? And put in, this is quite nice. We've mostly got a common denominator here. What about this 3? What I'm going to do is check what the question's asking. The question it's one of these show that questions. So it's saying I should be getting 3 plus 2 minus cos theta on sine theta. Okay, so if we reorder this, 3, and then we've got, this is plus, so we've got plus sine theta. We've got 1 plus 1 from here and here, minus cos. Now, of course, 1 plus 1 is just 2. So I'm going to go to that straight away. And I think this is our length equation that we're looking for. So just want to hide the work that I've done here. Well, that eraser's too big. There we go, that's better. So I'm going to hide this work for a second and check if my length equation matches their length equation. Otherwise, we'll have to do some rearranging. All right, so clear all for a minute. 3 plus 2 minus cos theta on sine theta. Good, so this is the equation we're looking for. All right, well, didn't want to do that. What I'd like to do is make some room for myself. So I'm going to write this length equation up a bit higher. Length equals 3 plus 2 minus cos theta divided by sine theta. Because I'm pretty sure what's going to happen next, like a lot of these questions, we're going to find the derivative of this and work out what theta needs to be when all of this equals, when the derivative, equals 0. Okay, we'll check what the question says though. It's always good to read questions very carefully. So show that, oh, we've got to show that. So we need the derivative, but we also need it in this form. Okay, and then we'll set it to 0, and that should be our answer once we've done that. All right. Okay. I might slightly rewrite it because I'm thinking it might be a bit overkill to use the quotient rule on this. I think when you have fairly simple fractions, it's often better just to jump in with the product rule to find the derivative. So if I write sine theta to the minus 1, all right. So we want the derivative. Now, derivative of 3 is 0, so that's done. And then we've got this product here, right? This function here times this function. So we need the derivative of that one, which would be, so the derivative of cos is minus sine, but we've got a minus cos. So we'd have sine theta times this function. Oh, this is nice. This will just equal 1. All right. Plus this function here, 2 minus cos theta times the derivative of this. Okay, well that'll be times minus 1 sine theta to the minus 2. That's the outside. We're using the chain rule here for this derivative. So the inside derivative is cos. All right, let's tidy this up. So we end up, this is just 1. Surely I can write that at this point. Oh, we've got a minus here. So we want 1 minus, now what ends up being on top of this? We'd have 2 minus cos theta multiplied by cos theta divided by sine squared theta. Now I can see a cos squared in there, but I'm going to do what you should be doing as well, and it's checking the form that they want the equation to be in. So they want it to say 1 minus 2 cos theta on sine squared theta. I don't think my equation looks quite like that. Let's have a look again. So the first thing is that they've got this 1 on a sine theta. I've just got a 1 by itself. And then it said minus 2 cos theta. Well, over here I've got a cos squared. We're going to need to do a bit more work here. All right. So let's start with, oh, I need my pen. Let's start with a common denominator, sine squared theta, for the whole thing. And we're going to expand this as well. So if I've got 1 and I give that a denominator of sine squared theta, I've effectively, times the denominator of this 1 by sine squared theta. I need to do that on top too so that that stays as a 1. All right, then what have we got in here? We're minusing all of this, 2 times cos theta, 2 cos theta, minus cos squared theta. And where does that take us? All right, so let's get rid of these brackets here. We've got a sine squared theta, we've got a minus 2 cos theta, and we have minus times minus there, so this is now plus cos squared theta, and it's all divided by sine squared theta. And you should always be on the lookout for this. Sine squared, anytime you start seeing squareds with sine and cos, in the back of your mind you think, well, I might have to use this trig identity, right? And just a very quick reminder, we're getting this one from Pythagoras, right? So if that's sine theta and that's cos theta, right? Now, the hypotenuse doesn't have to be 1. This will work, I don't know, if that number's 10, say, then that opposite length there will be 10 times here. And this adjacent length will be 10 times. And so when you come to, do Pythagoras on this, those 10s will cancel out. So you can always say that sine squared plus cos squared will equal 1. But I think we've covered that one enough. So what I've got down here is a sine squared plus a cos squared equaling 1. So I've got 1 minus 2 cos theta all divided by sine squared theta. Right, and I'm going to now double check. I'll just maybe write the derivative up here because I'll need to erase some of this in a minute. But I want to double check that I've actually got this equation right. Because if I haven't, I've probably made a mistake somewhere, so let's have a look. Bear with me, I'll just hide everything. 1 minus 2 cos theta, 1 minus 2 cos theta, yep, divide sine squared theta, good. So we're ready to move on, and we can erase all this working out. All right, can erase that as well. Now we need to find the minimum length, all right? When we're finding stationary points, minimums, maximums, points of inflection, we set the derivative equal to 0. dl on d theta will equal 0 when, you're thinking when? When will it equal 0? It will equal 0 when that top bit there equals 0, all right? When 1 minus 2 cos theta equals 0, okay? Now, it might be worth noting that theta cannot equal 0, okay? Because if it did, then the denominator here equals 0. I should have picked that up in the original length function as well, right? So we're not allowed to bring theta down to 0. These towns are stuck in place, I suppose, effectively. We're only allowed to move p, right? So that angle there cannot be 0 because then sine of that angle equals 0 and the whole problem becomes a bit of a nonsense, right? Okay. Therefore, what's next? Well, if we minus 1 from both sides, we'd end up with minus 2 cos theta equaling minus 1. But let's just get rid of those minuses. We could say cos theta has to equal a half. All right. So unit circle time, when does cos theta equal a half? Have you memorized this yet? So there's your angle there. Pi on 3, right? The coordinates on the unit circle, half, and root 3 on 2 for the sine value, but we're just interested in the cos value there. So it's when theta equals pi on 3. Okay. Now, just going back. Show that the minimum length of cable required. So we need to plug this answer here into our length equation. Okay, we'll just draw a bit of a line in the sand, so to speak. I'm going to do this over on the other side. So we want to know what's the length. Length equals 3 plus 2 minus, all right, well, we've already looked at this, 2 minus cos of pi on 3, it's a half. Yep, see ya. 2 minus a half divided by sine of theta is root 3 on 2, right? Root 3 on 2, right? So the length equals 3 plus, now this bit here is 3 on 2, 3 on 2, all divided by root 3 on 2. If I times this fraction by 2, top and bottom, what would it become? The length would be 3 plus 3 on root 3, right? Now that 3 there, you could think of it as a root 3 times a root 3, and it's divided by root 3. And you'd just be left with root 3. Or if you like, take the fraction, 3 on root 3, and rationalise that denominator. And you get 3 root 3 on root 3. They cancel. Sorry, mistake. You get 3 root 3 on 3, because root 3 times root 3 is not root 3. It's root 3 times root 3 is 3. And then they will cancel, and you're just left with your root 3. So the length is actually 3 plus root 3 kilometres. Okay, now let's go and check, because this is one of those show that questions, isn't it? So if we, there we go. All right, the length, it's a little bit hard to see with all my writing. I'll just delete that for a minute. So show that the minimum length required is 3 plus root 3. Done. Okay, thank you for watching. Until next time.